already on the podium. We have Narseo Vallina-Rodriguez from ICSI Berkeley and IMDEA Networks in Madrid. Narseo will talk about privacy leakage in mobile apps.
Okay, I'm going to stand in front of the lectern because otherwise you may not be able to see me. So the goal of this project is actually characterizing what kind of third-party services are collecting information about the users. And for that, we're using a tool that we have available on Google Play called the Lumen Privacy Monitor. So mobile applications collect information which could be very sensitive, from the email account to the IMEI, and they may use it for a purpose such as providing a better user experience or perhaps securing certain transactions that may be potentially risky. But they can also use it for creating a profile of the user. Android, as well as iOS, they try to protect the access to this information by enforcing a permission model. And that's the only opportunity that the user has at the moment to identify what kind of personal information they can potentially collect. So here we can see for this random game how they are actually collecting the IMEI of the user, as well as, the one on the top was the accounts of the user, and the bottom, the IMEI of the user. But the mental model that the user has is that this information is typically sent to the application developer. They are not taking into account that this could be as well leaked to third-party services for analytics and tracking purposes. The problem is that the ad blocking services that we have and the anti-trackers that we have are very web-specific. So they don't apply to the context of the mobile application. And we want to see how we can actually fix that problem at the moment. So in this project, we have three specific goals. The first one is actually identifying the third-party advertising and tracking services that are involved in that kind of activity. Then we want to evaluate the impact that they have in the user, but they can also have an impact as well in other metrics, such as the volume that the user is actually wasting on advertising. And finally, we want to create tools that will help to promote transparency and also to help users to stay in control of their data. Okay. And how actually do we do that? Well, as I said at the beginning, we have an application on Google Play. So far, we have in the order of 900 installs without much publicity, and I will actually encourage you to give it a try. And as I will show in this video, what it does is basically it uses the Android it uses Android VPN permission to intercept the all applications traffic on user space. And given that it runs locally on the phone, it can actually obtain all the personal information of the user. So we know exactly which one is the value of the user, of the IMEI of the user. We know exactly which accounts the user has. And we can also get, for instance, identify privacy leaks such as location tracking and other stuff. So in this video, you can see that, for instance, for one random application, which is, I believe, Marca, which is a very popular sports newspaper in Spain, they are actually collecting, and we can also identify which one is the organization collecting that information. And we can do that because we run locally on the phone, and therefore we can correlate it's a bit more technical at the moment, but we can correlate which one is the process owning the socket with the information that we have on the device. So we have access to ground truth about all these activities. We also, in a different view, we are also showing how much bandwidth they are wasting on advertising and tracking activities. So we have two advantages by running on the phone. First one is that we have real user stimuli, and we have also real network activity. This is very important because by attracting real user stimuli, for instance, yesterday I was flying from LA to New York, and I realized the United app is actually leaking the IMEI, but only when you're connecting to the United Wi-Fi network on the plane. So by crowdsourcing that, you can actually collect that kind of information. Otherwise, if you're doing it in the lab with static analysis, you may not identify that kind of activity. And also the network stimuli is very important because, for instance, we are analyzing what happens in users' home. So, for instance, we also have a great window about what's actually happening in the IoT ecosystem because we see which applications are scanning in the home network, we see where they are leaking information, etc. Users, if they want to, they can also enable a TLS proxy that we have in Path. So we also have a window about what kind of tracking activity is happening over TLS. We are collecting anonymized information about all applications activity. We are not collecting any personal information about the user. So for instance, we are getting application X leak to xyz.com, the IMEI, but we are not getting the value of the IMEI. we don't care about what users' personal information actually is. We want to understand how applications behave in the network. And as I said, we have so far around 900 users, and this has allowed us to analyze more than 2,500 apps. And now I'm going to basically describe how we identify third-party services to find out. We have a bunch of domains, but we don't really know which ones are actually engaged in tracking activities. So we represent, given that we have access to the context on the phone, we know that an application has contact a given domain. You cannot do it if you are, for instance, a proxy in the network. And we represent each one of the domains as a node in a graph. So here we can see, for instance, AccuWeather.com. And we know that, or we assume that AccuWeather.com is a third party if there are more than one applications contacting it. So it's a very simplistic approach so far. In this example, we can see that there are 3 applications talking to AccuWeather. 2 of them are their own applications, the free and the paid one. And there is also the HTC widget that is also talking to AccuWeather to obtain weather information. Yeah, again. Sorry about that. Yeah. But for instance, in the case of Urban Airship, which is a tracker, we can see that other 3 applications are talking to it. But how can we actually, well, with that technique, we can identify 446 third-party services so far. But how can actually distinguish between third-party services such as content delivery networks from those that are engaging in tracking activities? And that's actually pretty hard to do. So the problem is that if we rely on existing data sources such as EasyList or Malwarebytes HP hosts, or in that case, McAfee's URL classification service, we can see that some of the trackers are classified in very high-level categories. Come on. Sorry. Yeah, so here we can see that Flurry.com, which is a very popular analytics service, can be categorized as an internet service. So we cannot rely on existing data. So we have to implement our own analyzer, sorry, our own classifier. And for that, we take into account the behavior of those applications and those domains in the network. And also, we are trying to analyze, using natural language processing, all the information that we can get on the web about that specific domain. So that way, we can actually do some sort of analysis about what kind of services a given domain is actually providing. So with that, we identified so far 280 domains. I believe that as we are collecting more data from more users, we will be able to identify more. And given that it's a very small scale, we have a 4% false positive rate. We are actually developing now techniques to actually reduce that false positive rate. The problem is that, for instance, if you have the bbc.co.uk, they may have, for instance, an article talking about tracking activities, and therefore our classifier can misinterpret that this is actually related with tracking. But at the moment, we are actually having a better false positive rate. Interestingly, we found 58 domains that were not existing in any malware, or sorry, tracking whitelist or blacklist. And in this figure, you can see the CDF on the x-axis is actually the number of second-level domains reached for each one of the applications, which are related with tracking activities. And we can see that 60% of them, more or less, have at least one tracker. But interestingly, 15% of the apps connect to more than 5 trackers simultaneously. So you may actually argue that this is actually not completely necessary, but some trackers are, as we saw in the previous talk, providing services for applications which otherwise they will require a specific team to develop them, like crash reporting, etc. We also look at the popularity of those services. And here in this figure, we can see the penetration of each one of those domains across all the applications. The first one is crashlytics.com, which is a back reporting service, but it's also engaging in certain tracking activity. And the second one is the Facebook Graph API. Surprisingly, when I was looking at this data, I realized that Google services are no longer the most popular ones. And we were also curious about how many of those domains were actually present in the web. So for that, we crawled the top 1,000 Alexa sites, we compared the domains, and we came with the fact that 68% of them are also web trackers. Some of them are specific to the mobile context. Android, well, Google knows that collecting unique identifiers is a very sensitive matter. So all this information is actually protected with the certain Android permissions. But the truth is that this is actually supposedly. We found a command which is, you can actually invoke it on user space, which contains some system-related information. But that also has the MAC address of the device and the serial number of the device. And we have actually evidence of hundreds of applications using that technique to collect or to actually track users without consent. So this actually shows that those applications are, with certain intent, trying to track users without actually informing them about that kind of activity. We reported that to Google. I think this is part of the responsible disclosure, and they said that this is working as it's supposed to work. If you want to read more information about the results that we have so far, we will present them in the DAT workshop on Saturday, and the paper is available on arXiv. But we are working at the moment on making a longer publication. We're also trying to create a tool for users. And we want them to take control of their data, and we want them to actually understand what's happening behind the scenes with their mobile applications. We have certain mechanisms for that. The first one is what we're calling Haystack Analytics. So it's basically a web service where you can enter the name of an application, and if we have it on the database, it will tell you what kind of personal information they're collecting, if they're using HTTP or HTTPS. We have a lot of evidence of applications leaking unique identifiers over HTTP. And you can also obtain information about why a specific type of personal information matters. And you can also navigate through all the applications that are actually, all the domains that are talking to a given application and see the whole network of tracking activities within a mobile application or within the web ecosystem, mobile ecosystem, sorry. And perhaps you can see this more visually in what we call the Haystack Panopticon. This is an animation where you can actually see the different connections that exist between mobile applications and tracking domains. So the nodes in the center are domains related with tracking activities. And the ones in the outer circle are mobile applications. Blue dots are free applications. Green dots, sorry, let me go back. Green dots are actually paid applications, and the pink nodes are pre-installed applications. So if you search for a given application, in that case, I think I entered cut the rope. You can see the connections that exist between the mobile applications and the different trackers. And you can therefore navigate through the whole tracking ecosystem on mobile apps. I use this example, which is cut the rope, for a purpose. The reason for that is that we are analyzing in collaboration with other colleagues at ICSI in the usable security team, how applications, especially related with children activities or children apps, are actually engaging on tracking activities. We have certain, it's actually a quite pessimistic ecosystem. We have found applications that, according to the COPPA rules from the FTC, an application must request parental consent before engaging in any tracking activities. And we have found evidence of applications ignoring completely that rule. Actually, I was playing with Irwin, who is also one of the collaborators in that study, before with one application that is supposed to provide parental consent, and they are leaking the IMEI over HTTP. In addition to that, we have found as well certain applications that even contain malware, according to the safe browsing team from Google, when you open the privacy policy. So it's actually a very interesting ecosystem that we really want to illuminate in the upcoming months. So to conclude, basically I talk about a method that allows us to identify third-party services without actually having to perform any manual inspection. We use the data that we collect from anonymous participants on the Lumen Privacy Monitor app, and we want to promote user awareness and mobile transparency and also enable user control. And in the next month, we want to actually enable some sort of anti-tracking feature on the app that will allow users to block specific domains for specific applications or do a system-wide blocking. The reason for that is that if you use blacklists, you are blocking at the DNS level, and that can actually cause disruptions in certain applications. So if you try to block Facebook and you do it at the DNS, you're actually disrupting Facebook's app. So we are trying to implement techniques that will allow us to identify when this is actually related with a third-party tracking service or when it's actually legitimate. And I will be happy to get any feedback from you. I will be happy to take any question, and I actually encourage you to take a look at the app and give us any feedback. And actually ping me if you want to see a real demo of the app. Thank you.
Thank you very much, Narseo. I mean, it's really impressive. Everyone is talking about transparency, but when you actually see it, it's a different thing. So, questions? Yes, Nick.
Haystack app is it's how we used to call it. We had to rename it because it was very hard to find on Google Play. It's basically a marketing issue. If you search for Haystack on Google Play, you will have hundreds of applications. Some of them are actually involved in porn. So we had to change it.
So, hello? Okay, I don't know if this is working. So what you're doing is you're grepping traffic, right? You're looking in outgoing traffic for this.
Yes.
Right. So what do you think would be the next step? I assume eventually these guys that you're flagging now will maybe convert, right? And they will start using their own encryption schemes, not TLS, right? Encryption at the level of the application.
Yeah.
So what is your next what are your thoughts about this?
That's actually a very interesting question. We are so far supporting only base 64. So we can detect when applications are encoding the data over base 64. And we have also had some conversations with the team at Northeastern, because that will also allow us to identify certain obfuscations within the traffic. So that we are certainly working on that. But that's a very good point.
Okay. Thank you.
Other questions? I just want to make a comment. I think that all these applications are fantastic, especially the crowdsourcing part. I think a big challenge that we all face is getting users. Yeah. And I think that after a couple of years of doing this round of grants and producing the tools, I think we really need to consolidate also our efforts on getting more users and getting the word out. Thank you, Narseo.